Did you see that, Adam? Adam, you paying attention? Let me show you that again. Parking attachment. Now with guns like these. Hey, welcome back. Pull up a chair. I thought I'd build a bit more compact version of one of these classic boring heads, and maybe more suited to the size of work that I do and the size of machine that I have. And perhaps, if all goes well, a little bit higher quality. Now, I'll be honest, I've never really had any problems with these import boring heads. The real problems really come in with the boring bars themselves. And I thought I'd get into these boring bars a little bit, specifically these import sets that you see back there. I'm sure we've all got a set tucked away somewhere. If you've tried to use these as is right out of the box, depending on how lucky or unlucky you got, you may already be aware of how frustrating they are to get a good cut and a good finish. But as fate would have it, I stumbled across a video by a fellow named Lockcracker. Let me write that down for you. Who basically beat me to it. You may have won this round, Lockcracker. But I think he did a really good job on explaining some of the issues one runs into with these types of boring bars. These quality of boring bars. I'll put a link to that video down in the description. So this video will probably mostly be a build video. Building a boring head. Making some decisions. Probably making some of our own tools. And just all in all, goofing around in the garage. So there are a couple of things I'd like to do different. First, I'd like to make this, as I mentioned, much more compact. There's a lot of wasted space in here. So there's probably an inch and a half of space in here I can recover, which gets me back some Z height in the milling machine, which is always welcomed. While we're looking at this side, I'd also like to make a larger dial. This is 2/100ths of a millimeter per division. I think if I make this dial twice as large, I could get more divisions on there and hopefully a finer resolution. Hopefully twice that, 1/100th. It will be a metric boring head. The mill is metric, but it doesn't really matter. Let me sketch out, I think, what I have in mind here. More or less something like that. I don't have exact dimensions just yet. I think I'll just sort of make them up as I go along, see what looks right, and more or less spitball it for now. On second thought, you know what? Forget about the sketches. You know what might be easier? To just show you what the new boring head will look like side by side with the old one. So give me just a moment. I'm going to time travel about 2 weeks in the future and bring back the new boring head. This is one of those operations you really don't want to screw up. Tapers, tapping, thumb screws, tin, time travel. Really be careful not to time travel in metric. 1,500 years is just one tumbler position away from 2 weeks. So make sure we're going in the right direction. Alright, I found it. And a snack. This thing was rotten in the future, and here it's good as new. Alright. Man, I'll never get used to that. I'm a little surprised with myself. It looks like it turns out a little bit better than I expected. I think those engravings could use some work though. I'm looking forward to seeing how I actually did that. Anyway, it's smaller. See, it's much shorter. I get about 1.25 inches maybe back in overall clearance in the mill. Body diameter is smaller. And alright, there's a lot more divisions on there and they actually look legible. That chicken scratch at the top, I think, is meant to say 0.01 millimeters. And you know, I'm not sure if this move is legal, but since I've got this, I think I'm just going to break it down and take the dimensions off of it. That way I'm not spitballing, and hopefully the show goes smoother. .40mm body, 10mm tools, M4s on the locking screws, 20mm dial, 8mm thread, 4mm Gibbs screws. That's curious. I was going to make those 3mm. Alright, sweet. I think I got what I need. I'd best get this back to the future before I cause some problems. So I have some more chromoly here. Looks like I'll need a 40mm piece. And then about 110 should do it. That'll be 40 for the moving head and 110 for the body. Now I know you folks get a kick out of all the metal cutting shenanigans, but I don't know if I have it in me this time. I'm just going to walk this over to the saw and cut it off like a normal person.
Mommy.
What are the odds? So just like every other great story in history, ours is going to start off at the lathe. I've got the 110mm blank. This is going to be sort of the body of the boring head. with the integrated arbor. If you watched my mill tooling video, the first steps here will be essentially the same. Dimensions at this point aren't super critical in that we can sort of, to some extent, make them up as we go along, but concentricity is going to be a big one here. You wouldn't want your boring head all off-center. Wait, that didn't come out right. Last time I came across this chromoly, I had some trouble with chip control. So I'm going to give it a go with a positive rake insert. This I think is a DNMG, like a 6 or an 8 size millimeter, like a 1/4 inch. It'll be spinning at 1200 RPMs, and I'll mess with the feed rate and see what effect that has on the chips. So the chips look a lot better than before. I mean, they're not long and stringy, but I think that insert is undersized for the depth of cut I'd like to take. And it sounds terrible when I push it pretty deep. I'm back to the Trigon. I'm probably gonna have to deal with some strings. I just don't want this to take all day. All right, so that's about a thou over finished dimension. That's still pretty hot though. My money's on it coming right into size once it's cooled down. So this side now is the actual body of the boring head. I don't have too much to take off this side, so I'm back to the smaller positive rake insert. I'll turn the body size down, leaving a bit of a flange for the iso taper. And I'll probably leave, I don't know, 1/10 thou or so for a finished cut that I'll do last when I have the fixed part and the sliding part of the boring head put together. By the way, if you don't have a lathe file, I strongly suggest you try one out. You have a look at the difference between this and sort of your standard file. This is my beater lathe file. I don't know if you can see the pattern on there. Hold on a minute. I hope you can see the difference now. Cutting with a lathe file is just an absolute dream, relatively speaking. The angle that these teeth are cut result in a much more smooth shearing action compared to somewhat of a bulldozing action. You know, these teeth are almost perpendicular to the length of the file. Lathe files also tend to hold up a lot longer. You can see how, you know, the grooves that I've sort of permanently cut into this. This lathe file also happens to have 2 safe edges, meaning there's no teeth here. Compare that to here, or the other side. So there's less of a risk of, you know, marring or scuffing up already finished surfaces. If there's one thing to take away from this video, I'd say it'd be to buy good quality files. Well, I guess 2 things, hold on. Time travel is dangerous, and buy good quality files. You want to get a good file and a few file cards just to keep around. Keep them nice and clean. I keep my file card in my wallet. I used to be a big Nicholson fan, but I'm not quite sure what happened to their files, I don't know, 3, 4, or 5 years ago. Not what they used to be. So to look for older Nicholson files, this one happens to be a Heller. There are a few things as frustrating as trying to do file work with a bad file. Maybe slow internet. All right, there's the blank. Take it over to the mill. First thing I'd like to do here is cut in the dovetail. Something a little bit like that, maybe a little bit straighter. Problem is I don't have a dovetail cutter small enough to really get in there. So I think what I'm going to do is sacrifice one of these import boring bars. Now I know what some of you might be thinking, that's a heavy price to pay. Now the angle of this dovetail isn't very important because I'm making both the male and the female side. As long as they match, that should be fine. Now since the boring head is a little bit on the small side, I prefer a larger dovetail angle. I mean probably almost like 70 degrees or so. But again, it's not important. I'm just going to let sort of the material here dictate how far I can get. Somewhere between the 60 to 70 range should be fine. This rest was made for, I think, a 3/4 inch wheel. The wheel is 1 inch, so I'm going to have to close this chasm. Otherwise, it might suck the tool right down into it. Not sure if you can see that. It's about 65 degrees. Should be fine for what I'm doing. Now that was more or less the easy part. The trick now is actually making this thing cut. Maybe I can show you over on the surface plate. I'll just set this on a V-block and we'll take a sort of a dead-on view. So I'm just going to use my surface gauge here to kind of square up the top of that carbide. Now you're not going to see it, but I'm going to pick up the OD of the tool and then drop down half the diameter. Bring that back up front. And you can see how much higher the carbide is from the center line of the tool. I mean, the rake on a tool like this, I mean, have a look at that. It's so far past negative, it's defeatist. Now, I'm not going to get into the details here. Like I mentioned earlier, Lockcracker did a great video on it. But basically what we'd need to do to this tool is grind the top of that whole insert down until we're on center line. Basically cut off everything from the tip of that surface gauge up. And that would give us essentially like a neutral rake tool. Actually give it a shot at cutting. What I like to do though, since that seems like a lot of carbide to take off, is just roll the tool so the tip is about where we want it, and take all the carbide from that tip on back. So sort of cut off that wedge shape. This poor geometry is the reason why so many people recommend against these boring bars. So the tool looks like it's starting to come in pretty good. Last step is to just sort of hone these edges a bit. Now you could give this a few licks with a diamond lap, a diamond hone, but I've got one of these cup wheels on a bench grinder and it seems like it does a pretty good job. I polished all three surfaces that sort of make up the cutting edges. While I was there, I also took an opportunity to knock a very small round on that corner. The top faces at or slightly below center line, and the other two faces have a bit of rake. For sense of scale, this thing is 10 millimeters, about 3/8 of an inch. And what I usually do is take my best guess like this, start to make some cuts within it. If I don't like it, just sort of tweak some of those angles a bit. So I've already centered the work in X and Y. I'm just about to set the Z height. I'm just using a slip of paper here. This is about 4 thou, a tenth of a millimeter. This dovetail is going to be about 5 millimeters deep, and sort of the top is going to be 14 millimeters, I think. The exact size here isn't really written in stone. Any deviation, notice I didn't say mistakes, any deviation from the dovetail size I want in this part, I can just make up for in the mating part. Anyway, it's a 10 millimeter 2-flute end mill, about 3/8. I'm going to be cutting 2 millimeters deep, 600 RPM. I'll do that in 2 passes, and it'll leave me a little bit of material at the bottom for the dovetail cutter to clean up. Well, here goes nothing with the dovetail cutter. Now I just want to really clean up this top surface. This top surface is essentially the bearing surface between the moving part and the fixed part when the dovetails are locked. They'll sort of pull that moving part down and lock it against this surface. There'll be clearance inside of the dovetail itself. Now I think it's best if this top surface is smooth as possible, just so the adjustments are nice and fluid. That said, I don't believe it's necessary to do it on the surface grinder. In fact, I think I'm taking some risk having moved it from the mill vise to the surface grinder. But I think I trust the mill vise and this mag chuck enough to feel confident that this will work out all right. This could have been maybe fly cut on the milling machine, or chucked back in the lathe and just faced off with a very fine feed. Or heck, I mean, that's not very much material at all. It could be stoned by hand. The way the clamp is set up, it's biasing it back into the corner, and I've got the collar here that acts as a vertical stop. All right, so that's 175 and 23, 198. I'm gonna call that 5 millimeters and good enough. I'm starting to get the feeling that this video is gonna be a long one. But in the famous words of Benjamin Franklin, never put off till part 2 that which you can cram into part 1, yo. I floundered a bit as to what to do next. There's still quite a bit to do on the fixed side of the boring head, of course. And there's no real critical order of operations, at least that have dawned on me so far. But since I started off with the dovetail, I thought I might see that through. I did decide to make another smaller blank for the movable part of the boring head. The movable part isn't very tall, but I figured it was probably worth taking the diameter down now instead of putting a lot of work into this and then having trouble holding on to it. Now, I don't always measure dovetails, but when I do. So let's talk about actually having a shot at getting these dovetails to match. As usual, you'll need a couple of pins of about the right size for your dovetails. And again, right size looks something like that. They'll want to make contact about halfway up that dovetail. Now, I recommend you use a couple of pins with some light surface pitting. If you use brand new pins and your dovetails turn out sloppy, you'll have no one to blame but yourself. Drop the pins in. Make sure everything's nice and clean, and try to do a good job taking that inside measurement. And use a couple of gauge blocks, pick up that inside measurement. This now gives us our baseline nominal to cut the male dovetail to. Then as you're cutting the matching dovetail, you can occasionally drop these pins over and take that measurement. When you're measuring the outside like this, you'll want to add 2 more pin diameters because you've moved from an inside measurement to an outside measurement. But if you sketch it out on paper, what you're trying to measure with the dowel pins and everything in there, it'll become obvious. Now we can go back to the mill and start to build in sort of that hybrid gib/dovetail. Now, hold on just a minute. Pardon this interruption. I wanted to show you something. Would you just look at that color match? I mean, you couldn't do that if you tried. Really, Switzerland? I was a little concerned about the size of the M3 screws, but they're doing an excellent job of locking this head down. I've set them in firmly, not excessive, and the head just isn't budging. I'm really happy with that lock. Though to get that feel just right, I did come in and cut a little bit more of a relief on the inside of that dovetail. I undercut about another 60 thou, a millimeter and a half approximately. I just thinned up that little area there. Without it, I could get it to lock, but it seemed a little excessive, the force I needed to put on this very small Allen wrench. It was sort of borderline, will I strip the screw or will I strip the wrench? But just that little bit of added relief seems to have made a world of difference. I think I can now start adding some features to the moving part of the head. I'll bore this and start to take it to size. I didn't go all the way through with those. I wanted to leave a solid face on one end for a center. My next step is to take an intermediate sort of finish pass, the second to the last, if you will, so I can get both parts nice and concentric and set back up in the mill. Not really impressed with how this surface finish turned out, but I think I can clean that up. These scallops I think are more or less cosmetic. If you saw the clamp and you're wondering what that was about, it was just to help the set screws keep that mobile piece in place. The dovetail is very strong left to right and up and down, but the only thing keeping it from sliding are the set screws. So the clamp was just bridging the dovetail gap, just in case this setup had the funny idea of going south. Alright, so almost there. You saw me drill the cross hole, drill and tap the holes to lock the boring bar in. It's 90% there, it just needs a couple of features on the inside to interface with the adjustment screw. But before I bore for that adjustment screw, I'd like to make the final pass on the OD. Not that it's terribly critical. Alright, that works for me. You saw me indicate the dovetail vertical. It's important that the threaded adjustment hole is parallel to that, otherwise you potentially risk binding in the screw. I spot faced, center drilled, went in with a small drill bit all the way through, then took it to size, which in this case is 7 millimeters for an 8 millimeter tap. And now I need a 20 millimeter hole about halfway down, halfway through the thickness of this head, and that's where the adjustment screw will travel. I'm up to 14 millimeters now and I'm just about to break this wall. I'd rather not risk this with a drill, so I've switched over to, you can just make it out in the frame here. That's an 18 millimeter end mill. It happens to be a rougher, but it's not important in this case. After the 18, I'm going to follow it with a 19. I want to get to 20, but I don't have a 20 millimeter diameter anything to finish this hole up with. So we'll have to bore that out. Alright, so far so good. I'm up to 19, I need to get it to 20. Now the boring head that I have isn't really the best boring head in the world. Especially in a situation like this, where I'm using a very small, low quality tool to get inside of a small bore and spinning it at, relatively high speed. Adjustments aren't super smooth, and again, by the time I grind that down so that it actually cuts, I guess it's just a little bit of a gamble on how well that finish will turn out on the inside. I could sneak up on the size, but I wouldn't expect it to be mirror finish in there. And this is exactly why I'm building the smaller boring head. It'd be ideal here with a nice carbide inserted boring bar. Oh hey, you know what? I know just where to get one. Alright, now we're talking. Alright, well I don't know what you folks think, but from where I'm standing that looks pretty nice. Alright, I should probably hurry up and get this thing back. Oh boy, that can't be good. Holy smokes, that was a bear to tap. That's an 8mm by 1mm pitch, tapped about an inch deep, 25mm. This chromoly is some tough stuff. Alright, well things were just getting out of control and I had to stop and deburr this thing. If this thing nicked, scratched, or cut me just one more time, I mean I'd pass out from the blood loss. This dovetail just claimed another quarter pound of flesh out of my thumb. Sorry if that was disgusting. But I just managed to stop crying like a little baby long enough to pick up this video again. And there's absolutely no shame in crying. But just think of the alternative. Do you really forever want to be known as that guy they found dead in his garage wearing an apron? I'm using mostly this little slipstone, though these little very fine rifflers are coming in handy for some of the tougher to reach areas. Like in this slot, for example. There's not really a lot of other ways to get in here carefully. And these small curved files do a nice job. I've got the boring head mounted in the small 4-jaw chuck. It's centered and I'm happy with how it's running. The top slide is set up to cut that taper, and my top slide power feed is charged and ready to go. I've also turned down the end and tapped for the drawbar. Really the only thing left here is the taper. I sure hope that's the only thing left at any rate. Once I cut this taper, I really don't have any good way to hold on to this part anymore. Last up is that adjustment screw. Once I have that adjustment screw, I think I can cut the key, or the slot, in the mobile part of the boring head, put it together and try it out. So although the M3 set screws were doing just fine clamping the moving part of the head, future me was right. I don't have ball bearings small enough to fit in that M3 hole. So M4 it is. Slight change of plans. I think I'm going to go ahead and cut the slot in the moving side of the boring head first. I think it'll be easier to match the screw that I've yet to make to whatever dimensions I end up with here, rather than the other way around. No real difference, just a matter of preference. I'm holding the moving part of the head in the vise with the 2 dowel pins I used to measure the dovetail. That's in there pretty solid, but just to play it safe, I'm using the vise stop to just provide some backup. I'll be cutting the slot with a woodruff cutter. I made the woodruff cutter out of one of these old bolts. Just a couple of licks on the bench grinder and we're good to go. Back at the lathe and I've started working on the adjustment screw. I've chucked a piece of bronze up in the 3-jaw and gave it some tailstock support. If you don't have a 3-jaw chuck, you could just make one out of an old hydraulic jack. Give it a couple of licks on the bench grinder. Keep from boring the pants off anyone who might be watching this video wearing pants. I've already roughed this piece of bronze down. So that's 8mm blank to accept the threads. On the left will be the dial face, and in the center is the ring that'll drive the movable part of the jaw. The movable head mates up right there. So as you turn the screw, it'll drive the head off center. Now if only I could find my small thread cutting tool, I'd cut this thread. Threads have fits just like shafts and bores do. The reason I decided to thread cut this instead of chasing it out with a die is that I have a lot more control over the fit between the male and the female thread. Because I cut the thread in the boring head with a tap, you sort of get whatever you get from the tap there. Whereas here I have more control on the diameter to make sure I get the fit that I like. In order to hold on to this now, so I can work in basically the dial face, I drilled and tapped a piece of just aluminum cutoff for the same thread, and then split it lengthwise with a hacksaw. It just screws on and gives me something to clamp onto, both here for finishing the face and then later on the CNC to do the engravings. I'd like to slightly crown the face. And although you could do this with just a hand file, maybe a ball turner if you have one that can get in that close, I happen to have a form tool that's 40 millimeters. This will help me out on the CNC because I have now a known radius that I can engrave onto. Just hope this thing still cuts. I plan to cut the hex socket on the CNC router. Before I do that, I'd like to rough out as much of that material as I can, just because the bit that's going to be in there is so darn small. This might give me a bit more of a fighting chance. I'm going to drill out the 6 corners, and then center drill, the inscribed circle of the hex, which is 4 millimeters in this case. My apologies for not getting a wider shot here, but we're now on the CNC, set up to engrave the divisions. The plan is to do 100 divisions on that 20mm face. I'm cutting a few millimeters above the surface and eyeballing the gap to check if it's consistent, which it wasn't. The engraving is so shallow that even a few thou discrepancy in my surface would have ruined the whole show. Now I fought with this for a while and finally gave up and just milled the top surface in for a perfect match. And the surface finish was much better than I expected. I am also flattening it out a bit, dropping the center down. I'd like to 3D chamfer the bore this fits in, and a flatter dial I think will look much better. And here's the money shot. There's something special about CNC that reminds me of the simpler times. I hit the start button and I'm magically transported into one of those black and white Laurel and Hardy movies where I'm in a car going way too fast down a hill in San Francisco and the steering wheel just comes right off in my hands. Anyway, this is the first time I've done any engraving on the CNC and I'm pleasantly surprised with how well it's turned out. The V-bit here is homemade, and by the looks of it, it could have been sharper. It's pushing up a bit of a burr. The last step here was to mill the hex. Came out right to size, but the rounds in the corners are still a bit large for a proper key fit. I'll have to broach those, maybe. Well, I suppose nothing left to do than put this together. I really didn't want to cut down this nice little boring bar, but I suppose if future me did it, I don't have much of a choice, do I? Alright, well I think that's it. This is usually the part where I show you how this thing works, but technically, I think I already have. It bored its own countersink for the adjustment screw. Anyway, a bit of a long one, but I hope you like that. Thanks for watching.